Hello, people. This is one of the original 5 amp hour batteries that it's the old generation. Um, I had bought a non-self-propelled before I upgraded, and this battery is actually out of the one that's non-self-propelled. I gave it to my cousin because he was in desperate need of a mower. But this battery failed, and that just completely blew my mind because I used it before I gave it to him, and then charged it. Took the mower over to him. He used it once, tried to charge it, and it was done. I was like, what? So there's a story behind this. And I originally gave the mower to my uncle because he didn't have a mower at all. But he ended up moving away from where he was and didn't need the mower anymore. So I'm like, okay, well, let me have it back. And I'll give it to Bubby. Now, what I had found is traces of moisture before I actually took this board off. And yeah, that was my boo-boo. Those of you that watch my channel has actually seen me do stuff like this in the past. So, But moisture buildup right along here, and also various places on the board. Let me see if I can find some more. I've seen several places, but since I've taken it off and messed with the solder, I'm not seeing it now. But anyway, I tried to hit the reset, which is here. And yes, it can reset the battery to put it in charge mode. But if this reset don't work, then the problem is going to be one of your cells that is below the max level. Now, I've taken several of these batteries apart before, and the primary contact points for the batteries is scattered all over the place. Yeah, this one's done. You can actually see what each cell voltage is if you take the cover off of it. And I don't know what the hell Ryobi was thinking on this generation, but they literally filled that hole right there with plastic. I could not get that out for nothing, so I got ticked off and I was like, oh, what the hell? And I just broke the screws, basically. So that's going to take hot glue to get it back together. That is if I even use the case. I'm not planning on putting this back together because of the fault with the board. So far I found one cell row that was down to 1.9 volts. Now the fault level is going to be, my guess, right around 2.5 volts because your lithium ion batteries are not supposed to be discharged below 2.8 without losing major capacity. Anything below that they will lose. So post 1 would be here. Let's see if you can get that. If I can squeeze all this in there. Now I just got through charging one set of cells backwards, which is don't matter. This cell was 1.9, which the point to check on that is actually here and here. And then the other to check next would be here to here. This one is the other half. How they designed these batteries is you've got two packs like this, and course, this is a set that I'd taken apart before. They was all testing out at 1800 for the most part, so I took the cells out and used them for another project. Now, from an electronic standpoint, these electric mowers are not going to give a crap where the power comes from. It's just the same thing with the Ford Escape. They're not going to care where the power comes from as long as that battery voltage is where it needs to be in the range it needs to be. And I proved proof of concept with that Escape. It's just a shame that that monitoring board that I put in failed the way it did and killed the hybrid side of it. It's awful. And yes, that's my cat in the background. He's a Flame Point Siamese. But anyway, back to what I was saying. Yeah, these batteries are built in two sections. There's two of these that are screwed together by these points. Here, 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 and here. The ones that have already salvaged these batteries before, you're already going to know this, but the contact points to actually check on these batteries. And by the way, these two sections are facing each other, and there's a divider plate that looks something like this in between them to keep them from shorting out. So, with that being said, your contact points, I just got through charging this one cell. That's this battery row here, and they are actually in pairs all the way across. So you got the first pair that's here and here, which is 3.7 volts. There. And the second set, this bridge is going to run across two cell points, which is actually here and here. So you can see running here, this is your next contact point to check for your cell voltage. That's 3.5 volts, and that's fine. That is acceptable. This has not been charged. That contact point is going to be here and here. This does not matter because it's actually part of this side, the second half of the cell. The next contact point to go to check your cell voltage would be here, and that runs over to here. So that's covering 1, 2, 3, 4, 5, 6, which is pretty much normal. There's only 5. 1, 2, 3, 4, 5. There's 5 rows. So we got 1, 2, 3, and 4, and 5. That's 2.95 volts. That is a safe limit. So the fault with the board itself, it discharged this one and this one down to 1.9 volts, these 2 points. So that is the primary output that jumps over. It does a cross here between both batteries, between both of these. So that's you got a jumper lead that goes here, and that's actually ground, so that jumps over to the positive on this. That doubles your voltage. The overall pack voltage for the 5 cell rows should be up around 20 volts. So that's ground here and positive here. Now these batteries are low on charge, so they're not going to be 20 volts overall. Now the next overall voltage, I haven't done anything at all with these. In fact, the only row that I've actually charged was this one. I recovered 1700 milliamp hour. Yeah, 1653 is what I recovered. The cell voltage was 1.99. That's really too low, but your capacity is not going to be a major loss if it don't repeatedly happen. Now, if you try and keep using this same board and you hit the reset and it does work, you can expect it to happen again because there's a fault with the board. One thing that can be done is use this point that runs over to here, which on the cover, this pin is positive and this pin is ground. And you can see that by this point being positive and this point being ground. Now if you want to tell Ryobi the big middle finger, you're not paying $180 for a replacement battery. You can use this point as a jump. Do not pass this. That is a fuse link, so if anything major catastrophic happens, that fuse link will blow. This is positive. Through the fuse link to the positive lead, solder your wire, make it 10 gauge. Don't use 14 or 12 gauge on that. That pulls a lot of power. And believe me, I had to upgrade mine because I tried to use them 14 gauge and I was like, whoa, Nelly, that wire's getting hot. Nope. Upgraded to 10, perfectly fine after that. So this is your positive, and this point is your ground for your battery output. Alright, now the 2 points to check for overall voltage for the 5 cells on this side would be here and here, and they're 17.3. So individual cells is going to be here to here. And if you take a look at the board for the pins that I'm pointing at, you can easily see major or minor. So that's here and here, because that's a single row. You always want to start with the single, because it will go from that single on your output over to a double and then jump down to the other branch. So you go here to here, 3.2, and then from here to here, 3.4, and then here to here, 3.6. Now this point jumps over to the other side of the cell pack, which is over here. And then let's see, where was I? From here to here? No. Let's see. Here, 3.2. Here to here, 3.4. Here to here, 3.6. From here to here, it's 3.58. So that's 1, 2, 3, 4. Where's it? To here. Yeah. Okay. Because it'll jump from this double point to this cell row, drop down here, and then there's a band that goes across on the inside of these that comes up at that point. So that's pin 5. Battery out, and of course the meter stops. Hopefully you guys are getting this yet. Here, 1, 2, 3, 4, 5. 5 points on each side that need to be checked for individual cell voltages. If any of those is below 2.8 volts and the battery will not charge, you may be able to get it reset if that one cell is not too far below 2.8. Hit the reset, put it in charge, and see how long it lasts. If it happens again, don't do it anymore. That's when drastic measures need to be taken. You can use this board as an adapter. And yes, this wire is too small. You can use this board as an adapter. That's the bottom half that plugs into the mower itself. Your positive and ground output is going to be here and here, which bridges over to here and here. Which one is positive? Okay, so silver is what I did for positive voltage out. The voltage combiner is here and here. So there should be over 30 volts at those 2 points. No, it's only reading half. It's not combined together right here. Yeah, okay. Take a look at this circuit board right quick. Yeah, that's voltage out, but I don't have the combiner. This is your ground. This bar adds as a combiner for from positive to negative to double your voltage. Same capacity or runtime for those that aren't familiar. But if I run the bar from here to here, the voltage out will double. And all it's really concerned about is it gets 40 volts here, goes in here and here. This don't matter, but you do have to get your positive max voltage. So for this battery, it would have to have a replacement BMS. There's all kinds of videos where you can where they can teach you how to add a BMS to it. It would need to be a 10S, and 20 amp will not work. It'll get you about 5 feet and shut down because the BMS is too weak at 20 amp. You need no less than 30. 40 would be preferable, but these cells are rated at 10 amp each, and I actually built another battery for that mower. Now these are salvage cells. They're 1 amp hour a piece. I put 6 of them together in parallel and 10 in junction, but I used a 20 amp BMS, and this thing will get you about 5 feet down the yard and then shut off, and you got to unplug it to reset it. And then 5 more feet. And I was like, okay, that's junk. That's got to go. I doubled it. 40 amp. Each cell is rated at 10 amp max. To keep your efficiency up, to draw less power, your batteries have to run in parallel. So if you've got a 10 amp draw between 2 cells, that's actually going to be 5 amp between each one. It cuts the power in half, basically, because you're running cells parallel. I've got another BMS coming in for that one. As far as this battery goes, I think the capacity on this one's still going to be okay. There's no point in throwing it away or dismantling it. I can actually set a BMS to this. I'll have to bridge these 2 points together and then run my BMS leads to all these others just to get it usable. Ground. $17.3 for that one. And 17.3 for that one. According to each side, they are perfectly matched as far as voltage goes. So this battery as a whole, with the new BMS, will charge just fine. That's about all I wanted to talk about. I just happened to see a video about Ryobi batteries, and well, if these do build a fault to drain a cell down to 1.9 volts, the board is faulty. If the reset works, that's fantastic, but most likely it will happen again. And every time that happens, it damages the cell even farther and puts you closer to having to dig money out of your bank to replace the battery. The best option, you need about 370 Celsius to get this circuit board off with a good soldering iron. It's got to be a good one. These hold a lot of solder, and if I had thought about it, I could have documented taking that circuit board off. There's actually a few screws. There's a few screws that mounted on here, 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 and here. You take those screws out, well, it looks like this one's a blank. Yeah, so it's actually right here for this one. You take those screws out, desolder everything, take the board off, and then use this cover set it back in place with hot glue. You can take that off, just break it off, desolder the FETs and take it off or whatever, and you use your contact points for here and here to feed the mower. Of course, this plugs into the mower like always, and if you need to remove it to charge the battery, then okay. But actually, if you're only going to use a built battery, you can leave this plugged in. There's a cable, and a cable like this. I forgot what those are called. I haven't done a video in so long. XT60. Yeah, but it's XT60. But I forgot what they're actually called. Anyway, your contact points are here and here on the circuit board itself. Turn this the same way. This would be sitting up here, so you're looking at this point and this point's pretty much the same. But after I got to looking at this one, I think I determined that the best option was actually go to here instead of here. So that's what I did. It actually runs straight to the contact point over here for ground. I think I should probably trace that. Meter is junk. There we go. Alright, got this, and this. No contact. Yep. So this point runs over to here underneath this plastic. And that's what it did. And this point actually comes up through the circuit board right there. Can I turn my light on? Yeah, I turned the... It is right there. That's your contact point that you need. Bottom side of the board is where it runs to, going to ground. Of course, this is going to be facing your plastic casing. Like that. You'll have this removed. This ends up being an adapter you plug into the mower. You're good to go. Then you've got a battery. Just recently built another battery. Where did it go? Oh, it's over here. Just recently built this battery. It's actually 40 volt, 10S, 6 amp hour. These cells are 3 amp hour rated piece. And I may end up having to change that BMS board. It's a safety board for those that don't know what BMS is. It's a safety board that regulates the power coming out as a safety measure. It will not let an item overdraw from it, and it will shut down when one cell drops below 3 volts. It cuts the battery off. And in order to charge it, you got to have a separate charger, because the Ryobi, when you go this method, the Ryobi charger is garbage. You can find a lithium-ion compatible charger like this on Amazon. And believe me, this is not sponsored. These are about 30 to 40 bucks, right around there. I've had it for a while. You plug it up. And of course, due to being for battery charging on the Ryobi batteries only, I put an XT60 on it, on the end of it. I cut the original off and put that on it. And the charger has a green light when it's got power. There's also a built-in fan on it. And all you have to do is plug it in. Light turns red, and when it turns green, it's done charging. And that's it. So instead of packing around Ryobi batteries, you're actually leaving the adapter in the mower, and you've got a battery block. And it takes some effort to build these batteries. It really does. And there's a due process to get them done. But this is getting much more advanced than some people are going to be willing to do or understand how to do, and I completely get that. But you know, I wanted to try and make a point. If you've got to go this far with these batteries to be able to use them, for an average consumer that understands nothing about electronics and does not want to dig in and is scared to get shocked or cause a burnout like that because you're using a soldering iron and you really don't know what you're doing. Well, you know, I do know what I'm doing, But stuff like that still happens because you really get into trying to get it apart or get it together, and you just make a boo boo. I mean, it's just plain and simple. It happens. But there are videos out on how to build these batteries. There's also cell holders available to put the cells in, but I've got a 3D printer and I print my own. It's just easier that way, and actually it's cheaper, but over the long run. But if you're going buying a 3D printer just to print cell holders and miscellaneous stuff, well, on the short term, it gets quite expensive really quick. But stuff like this, you know, the 6 amp hour battery that's hand built. I've got a 9 amp hour battery that I built a while back. Oh, it's over in front of my desk. Nine amp hour battery, except this safety board, BMS, is actually it's got a separate input for charge. Actually, I wish I hadn't done that, but yeah, what can you do? 9 amp hour. I'm not too sure if you guys have seen my yard. Those that have watched other videos where I've been in my yard definitely have. I've got a 70 by 100 lot. I live in a mobile home. This 9 amp hour battery can mow the entire yard 1.5 times. That means the front yard, the backyard, plus half of the front on 9 amp hour. 6 amp hour, I can practically mow the whole front yard with it and a few lanes of the back, and that's about it. So the less power you drain from each cell to get a task done, the longer the run time is going to be. If you've got a 6 amp hour battery pack and you're pulling 30 amp, that's 15 amp per cell. And if the battery is not built to do that, it will get hot. I guarantee it. I'm actually surprised this one's actually showing a charge. Showing it's charging. So I've been working with it, but no, okay. Anyway, people, just wanted to get that out there and clear things up on maybe if somebody has any questions on what the repercussions of hitting the reset button on that circuit board could possibly be and what the long-term effects are. Now you have it. That reset button may work, it may not. If it does work, fantastic, but if it does it again, the battery needs to be replaced. Or you can just keep hitting the reset button until that one cell is totally dried in capacity and the battery only lasts 10 minutes, and then replace it, because that's what would happen. But you know, if it starts doing it, you're best off tear it down, put a BMS safety board in it, and just work with it. You know, there's all kinds of information out there where you can build your own batteries. But as I was saying, this point to this point would need to be junked. Let me see if I can find something. As it shows on the circuit board, yes, point needs to be jumped. Here it is. Get my little alligator clips. Okay, so the whole battery pack set should be out here to here. Move this out of the way. Oh, that is going to be turned. Ground. Make sure this generic thing's going to read. Nope. Okay, so that's ground. And the positive lead should be here. Unless they've got it turned. And the jumper there to there. They may have it jumped. Twisted around. From there over to here for jump to the other pack. And output positive is here. Output ground is here, but going through the FETs would be here. And that puts jumping from here. Now this is going to be a bright flash if this is wrong, but I don't think it is. You guys see the meter? Yep, there we go. $34.6. I realize you guys are seeing that sideways, but sorry about that. But there you go. So you got a jumper from this point to this point. Your outputs are here and down here. Yeah, and it's one of the big posts. That's if you want to salvage this battery and make it reusable. But if you do that, these points are designed to face this board. And due to the build on the battery, it's actually flat faced here because of the board. But when you turn it over, it's actually high set, not flat. So what you could do is cut a hole in the top cover if you want to put it back together. But you would have to use the BMS and work out your input for your ground, and then run your output from the battery to here underneath the battery. Kind of a pain. Just better off to use this as an adapter. Put an XT60 plug on it and hot glue this in place. Run your ground here, positive here, and plug it in. Be done with it. That's what you're better off doing. And actually, there are 42 volt batteries that can be bought. Maybe straight from China. It could be some on Amazon. I know I've seen all different voltage type batteries because of e-bikes these days. You need 42 volts max charge. It'll be a 10S battery, and most likely it will come with a BMS naturally, and depending on how the manufacturer put the battery together, it could actually be an XT60 input plug or output, which is going to be the male version. This is female here. That's for input. And these are for output. Put that back on charge. I might try to use that on my mower today. Well, we're supposed to get rain at 1 o'clock. I tell you, I can't get nothing done for this stupid rain. But anyway, hope that answered some people's questions on what's going on with these Ryobi 40 volt batteries. You know, it's kind of unfortunate. You know, I did see there's traces of moisture going across that. I've seen some others. I do remember right in here, and also over in here. Most of that trace of moisture has been removed because of me doing the desoldering on trying to get it apart. So it's almost like the battery was dropped in a puddle of water, and some water worked its way in and fried the board. But I'm done. You people have a good day, and if you work with these batteries, play it safe, because they are 40 volts. There's a lot of current, and if you short one of these out a little too hard, there's going to be burnage. I guarantee it. Until next time, people, it's hard telling what I'm going to talk about next. And actually, I think it may be my Saturn. I found a fault that Chevy, well, shame on them. But that's another video. Okay, well, anyway, until next time, people, you have a good one.